Hi, everyone, and welcome to today's webinar. My name is Jason Walls from QA Cafe. Today, we're going to be talking about performance testing of broadband gateways and Wi-Fi access points. So I want to talk about the different aspects, like the difference between throughput and latency testing, and why testing at the transport and application layer is more valuable than just layer 2 throughput, which is what a lot of tools focus on. Secondly, we'll have a brief discussion about how a device's regular operation can affect performance. So bugs in code or memory leaks can cause serious degradation of performance after you do, hundreds of HTTP requests or DNS queries after they're processed by the system. Then we'll talk a little bit about application-specific latency, like DNS, and how it can affect the user experience. And then lastly, we'll talk about having a tool that combines all of them in an automated environment specific to gateways and APs can help you develop and perform regression testing faster and easier. All right, so what do we mean when we talk about performance testing on a broadband gateway or on an access point? We're really talking about the device's network processing ability. That is, the device's ability to handle and that includes routing, forwarding, consuming or emitting packets. Depending on the design of your device, this might be a dedicated network processor or part of the overall chipset design. Packets are sent using a client or source that sends packets to a server or sink. The packets sent and received are then compared, and the client figures out if what it sent was received. For gateways, you can test the network processing between WAN and LAN or on the home network between LAN ports and get different results, especially over wireless. You can also test bidirectionally, which creates two sources and two sinks, and this will put a lot of strain on the processor. Now, many performance tools and processes use lower layer, like layer 2 or 3 packets, and that's all well and good if you're looking for a simple line rate measurement, but it won't exercise things the device is supposed to do, like, that is, deal with different applications that users actually use. The other thing to take note of is what the source and sink actually compare during the test. At the transport layer, it's the actual success of the transmission that matters, which gives us different results for TCP and UDP. Since we'll be retrying lost packets in TCP, the actual packet loss will just be a factor, but not part of the actual success of the transmission. You'll see latency issues rather than throughput. But in UDP, loss of a packet will generally show a loss of throughput. And speaking of throughput versus latency, the difference is that throughput measures the data rate of successful transmissions, whereas latency measures the delay between when the transmission was sent by the source and when it was successfully processed by the sink. Latency causes different problems with different applications. For example, if you're watching a video in a high latency situation, it will require more buffering by the receiver, or else you'll see delays. Both of these factors are affected by the performance of the device's network processing. And this is all very subjective, of course. There's no right answer on what good throughput and latency are. And users will have a different tolerance for different application performance. And when you add Wi-Fi to that, it gets extremely messy. So what sorts of things affect throughput and latency? The first is, of course, that the network processing just can't keep up with the demand and drops packets. And this will affect throughput if the packets never get there. But retransmissions at lower layers will introduce latency. So this may be out of the hands of the network processor. If there's like a disruption at the physical layer in DSL or Wi-Fi, retransmissions technology exists at that layer to make the connection robust, but it might introduce delay in your performance numbers. If there's a bug in your code or bad cleanup that's causing memory leaks, this can eventually affect the network processing ability of the device. And this is often due to the operation of other protocols. We've seen this before. I'll actually show you an example. So the first thing I'm going to show you is this baseline performance. This was a 1 gigabit Ethernet router that you can see is achieving close to line rate. And the reason why it isn't exactly line rate has to do with the way that the calculation of throughput goes, because we're measuring how much data has gone through. We actually have an article that I'll link to you at the end of the webinar that explains how exactly we make that calculation. But if you see, we call this poor router. Yeah, we have an example, it'll remain nameless, and we found it had performance that was drastically affected by continuous operations. So we ran this for a very long time, and while we were running it, we're also running other types of tests, so like DHCP renews and HTTP requests and that kind of a thing. And you can see that after a certain amount of time, it dropped off to almost 10% of the actual throughput. So this can happen. And, it's one of those situations where you're going to have to judge for yourself how exactly your team solves these issues. If it's just relying on the user rebooting the device, maybe that'll solve it or not. But you definitely want to see this stuff happening. So let's talk about application latency. So while baseline throughput and latency are good metrics, what we really want to know is how the device handles particular applications, because that's what the user is going to experience. And since these are subjective, we want to look at changes over time. So do we see any severe changes? So you're measuring latency of a particular application and running other things with it to kind of simulate what a user would be actually doing. And do you see anything get tripped up and suddenly become much worse in terms of latency? And in CD Router 10.4, which will be released pretty soon, we've actually introduced these application-specific latency tests for protocols like ICMP, DNS, or DHCP. So here's an example of what that visualization looks like. So you can see here we have 4 different lines, and it's basically the latency of 4 different protocols. And I mean, you can judge the actual latency numbers, but what you really want to see is if there were any drastic changes. These aren't really drastic because we ran it on a router that was actually doing pretty well. But you can see here that between this test and this test, there is an increase of almost half a second, right? So if you see something worse than that in results like this, it's going to be evidence of something wrong. And so it's something that's really good to run over and over again, but particularly you want to run it, like we said, it's highly subjective, and you're going to end up building your own metrics. But what we really want to know is how performance will change over time due to the real world behavior of the device. And that is, as users see it, will the performance change? And testing this in any way that can provide empirical results requires repeatability and consistency. And we want to be able to mix performance tests with functional tests to simulate user activity while we're doing these performance tests. So if we do a bunch of DHCP renews, is it going to cause memory leaks? What sort of things will affect the network processor over time? CD Router Performance add-on lets you build test packages that do these combinations and executes them consistently. You can set your own thresholds for success and failure. So if you know that 90% is the number that you're looking for, you can do that. And it, of course, also works with continuous integration through the CD Router API. So if you're trying to improve performance with firmware revisions, you'll be able to do that. So let me just show you where some of that is, if you are a CD Router user. So we're going to go to these baseline line rate performance here package. And it's using this perf setup configuration. So I can go here and find. So you can see under the performance add-on here, you can set the download thresholds, upload thresholds, the application thresholds. And so those will end up being the criteria for the pass and fail when you run these particular tests. So a couple of other resources I want to mention. Obviously, if you want to check out the CD router performance add-on, you can find it here. And we do have an evaluation license available for that, so you can try that for a period of time on your CD router system. And then that article I was talking about understanding performance results and how exactly we do that calculation is in our training guide. So if you look at that, we have some good math there about how that works. And the performance users guide will explain everything about doing the setup and which tests to do and how to run them and how to set those metrics. And the other one thing I do want to mention is that we understand that there are a lot of people that are going to start building devices that do more than 1 gigabit per second, and particularly with Wi-Fi. And so we are going to be adding 10 gigabit throughput on the NTA 1000, on the next version of the NTA 1000. All right, well, thanks again, everyone, for joining us. And if you do want a recap of this, we're going to be doing it again in about 4 hours at 1800 Universal Time. So yeah, thanks so much. And we look forward to having you join our next webinar. Have a great day.